Hi everyone, welcome back to my channel. In this video, we'll solve the following differential equation dp dt minus 1 by t times p is equal to t square plus 3t minus 2. Note that this is a first order linear differential equation, linear ODE. Now we know that this first order linear differential equation has the form dp dt plus a of t times p is equal to b of t. So then by comparing, we get here a of t is nothing but minus 1 by t and b of t is t square plus 3t minus 2. So we know the formula of integrating factor is e to the power integral at dt. Now what is at? It is minus 1 by t. So by solving the integration we get e to the power minus ln t. So by simplifying this we get e power ln t inverse, which is nothing but t inverse. So here we get integrating factor is t inverse. So multiplying by integrating factor t inverse in the both side of the equation 1, we get ddt of p times t inverse is equal to t inverse times t square plus 3t minus 2. We get pt inverse is equal to integral t plus 3 minus 2 by t dt. So by solving the integration we get t square by 2 plus 3t minus 2 ln t plus c. That means p is equal to tq by 2 plus 3t square minus 2t ln t plus ct, which is the general solution.